Hello everyone, my name is Akshay and welcome to our channel of this GFG POTD streak of day 93. So if you are new to this channel, please like, share and subscribe so that we can learn and grow together and maintain our streak together. Okay, so let's jump to the question now. So today's question name is GCD array. It's a medium category question. And let's start reading the question now. That you are given an array of ARR of length n and also a single integer k. Okay, so your task is to split the array into k non-overlapping, non-empty subarrays. For each subarrays, you calculate the sum of the elements. Okay, the arrays which you have split, you need to calculate the sum of the elements in it, and let us denote these sums as s1, s2, s3 till s of k, where s of I denotes the sum of the elements in the ith subarray from left. Ith subarray from left. Okay, so it's s1 is nothing but the ith subarray from the left. Okay, so okay. So s1 is nothing but the sum of the subarray that you have chosen from left to right. Okay, got it. So let G will be GCD of S1, S2, S3 till S of K, and find the maximum value of G that can be obtained. The array may contain duplicate elements. Okay, so let's see our first test case and let's see that if we can infer something on this test case or not. So for n equals to 5 and k equals to 4, the array elements are 6, 7, 5, and 7 and 3. And the explanation is like, since k is equals to 4, you have to split the array into 4 subarrays. And for the optimal splitting, split the array into 4 subarrays as follows. That take the first element as first subarray, the second two as the second subarray, 27 as the third one, as 3 as the fourth one. And if you see now that S1 will be 6 and S2 contains two elements, that is 7 plus 5, 12, S3 27, S4 is 3. So if you calculate the GCD, it gives 6, comma 12, comma 27, comma 3, that is 3. And it can be shown that 3 is the maximum. Okay, so as per they're saying that 3 is the maximum GCD if you split this array accordingly. And one thing you can also observe is that they are not taking any random elements. They are taking always in order. Like they have first taken 6 and they have not taken the random elements like 27 and 3. They have not done that. They went in the sequence, that is from left to right, that is this line was saying elements in the ith subarray from left. So I think that's compulsory to follow the order. Like you can pick up elements from the left to right, and you cannot leave any elements out. So 6 is there, and then you can see 7 and 5 is picked up, and 27 and 3. So though no random picking up the elements is allowed. Okay, so now this thing makes the question simple if they are going in one direction. But let us confirm this using the second test case also. So for n equals to 3, k equals to 2, the array elements are 1, 4, and 5. And since k equals to 2, you have to split that into two subarrays in and also in a direction, right? So for the optimal splitting, they have split this 1 and 4 at one subarray and 5 as another. Okay, so we are confirmed now. So this line here, that the elements in the ith subarray from left and this non-overlapping. This means that you cannot overlap, like you cannot choose two elements, the same elements in multiple subarrays. That if you have chosen 1 and 4 in the first subarray, you cannot choose 4 and 5 in the second one. You have to choose from the remaining one. And one more thing, that you have to move from left to right. So there are 2 points now. No overlapping. It should not be empty, and you need to follow a direction that is from left to right. Okay, so S1 will be 1 plus 4 and then it's 5. Okay. And we have the constraint as n equals to 10 power 4, so we can go actually n square this time, right? Okay. So let us copy this test case. I will copy the small test case here. And 2 points that I was able to infer, that there is overlapping not allowed. Not allowed. Second point was you need to go from this direction to this direction, that is from left to right. And you have to pick all the elements. That means the overlapping is not allowed, right? Okay. So let's break the question from the question itself. So this is the thing, right? Let me copy this line. Question is saying like this. First of all, these mathematical types of question, there is no hard and fast algorithm that you can apply. You always have to a good grip on this number theory, and you have to consider the question and then solving in that direction. Like use the question to solve in a wave, in a row, in a particular direction. So what I say, that using this equation I can say that S1, since G is the GCD of S1, S2, S3, and Sk, then I can say that S1 is a multiple of g, and I can write it as x1 is equals to x1g. Similarly, I can write for a s2 is equals to x2g, right? And s3 is equals to x3g. X1 and x3 are just the random numbers. You can write it, right? If I'm saying that 6 is the GCD of 12 and 18, let's say, then I can write, right? I can write that 12 is equals to 3, 12 is equals to 2 into 6, right? This is S1, this is X1, and this is G, right? Now I hope you can relate this point from here. So similarly, I can write S of K is equals to X of K into G. And if I sum this up, then I can see that S1 plus S2 till Sk is equals to X1 plus till Xk is G, right? And from this point, I can say that G is factor of, what is this? S1 is to Sk. Since we are taking each element once and we are forming this sub arrays, right? This is actually our S1 and S2, right? So I can say that the sum of S1 and S2 is nothing but the sum of the elements. Sum of the elements. So I can say that the G is the factor of sum of elements, right? So this G will be our answer. This G is our answer, right? And that means that we need to find the factor of this sum. First, I need to compute. See, the question is telling me everything. First, I need to compute the sum of all elements, right? Second thing I need to do is to find the factors of this. Let's say I have stored in a variable called sum. Second thing I need to do is to find the factors of this sum variable, right? And the third thing I need to do is, now G is the answer, right? And in the G, we need the maximum value of G, right? So suppose for this 1, 4, and 5, the sum will be 10, and the factors will be 1, 2, 5, and 10. And I need the maximum. So whatever pre-computation or pre-processing or the condition I will go on this, which one of the G would be answer, I need to start from this side. Like I need to sort it first of all. I need to sort the all the factors, and if you see 1 to 5 and 10, it's a sorted order. And I need to check the conditions that this G is answer, this G is answer, or which among these four numbers, which of our G is our answer, right? And this is pretty obvious that we need to start from the larger G to the lowest G's. And as soon as any of the G satisfy a condition, we'll just break it from there. That will just break our loop from there, right? So what I need to do the pre-computations here, what should be the condition that I need to maintain? So I can say that among this G, G is nothing but the highest factor of sum, right? And which is what capable of, which is capable of dividing k pre-sum values. Now what is this k pre-sum values? K pre-sum values is nothing but we have this array element as 1, 4, 5, right? So let's say suppose this was the S1 and this suppose this is the S2, right? So this is, so I can say that this S1 and S2 is nothing but k pre-sum values, right? I can say that. So I need to find pre-sum in order to check that which among of the G is actually our answer. I need to find pre-sum. Why pre-sum? Because this S1 was itself the sum of the elements, right? Sum of the elements which chosen in this S1 set. So so what will be our, so before moving ahead, let's code these three steps first, and then we'll move ahead. Okay, so I will make a int sum is equals to 0, and then I will say for int I equals 0 to I less than n I plus plus sum plus equals to array of I. This is nothing but sum equals to sum plus array of I. This is just the shorthand operator you can write. And step 2 will be the find factors of this sum, right? And since we don't know how many factors will be there, so we need to maintain an array list, right? So let's make an array list now. So array list integer, and what, let's give it a name factors, because what we are doing, we are finding the factors. So new array list, right? So let's find the factors now. So for int I equals to 0, no, not 0, the minimum factor will be 1, right? And all the factors we can compute till the square root of n, right? Suppose we have the factors from 1 to n, whatever number bunch of numbers. So if we iterate from 1 to square root of n, we will get all the factors, right? How we can get that factor? Let me just explain you this tiny thing also. This is a very simple thing, but let me explain it to you. So let's say we have this number 10, and I'm saying that just iterate from I equals to under root of 10. And under root of 10 is what? 2 to the 4, 3 to the 9, and 4 to the 16. So 3, right? The floor value will be 3. So I'm saying iterate from 1 to 3. So for I equals to 1, I will check that if 10% 1 is equals to 0. It is 0, right? So I will add 1 in my array list, as well as I will add 10 divide by 1. That is its pair, that is 10. These two becomes pair, right? So for I equals to, I will see that if 10% 2 is equals to 0, that is equals to 0. So I will add 2, and then I will add 10 by 2, that is 5. This is the pair. For I equals to 3, you cannot divide this thing, and we have reached 2 until our root 10, and we will stop here. And as you can see that we got hold of all the factors 1, 10, 2, and 5 in root 10 time. Okay. Okay. So what I can write, so if sum percentage is equals to 0, then factors dot add of I. At the same time, I need to check and then add. So I need to check if I is not equals to sum by I, then add that sum by I also. Factors dot sum by I. Why I check this thing? Because there may be a case of number, let's say 36, where this number is a perfect square. So for I equals to 6, the 6 will be divided by 36, and if you check that sum of I, it will be again 36 by 6 equals to 6. And we don't need to add 6 twice here, right? That's why I'm checking this condition. I hope that is also clear to you. That was a very minute point, but I still explained you. So now the array list is having the numbers as 1 comma 10 comma 2 comma 5, but I need to traverse in one direction. I need to first check for the maximum possible g, and then if that's not answer, then we need to compute the second largest possible g. So I need to sort it, right? So I will sort it. So either you sort it in the ascending order or descending order. If you sort in ascending, then you have to traverse from the, suppose if you sort it in ascending order, so it will look like 1 to 5 and 10. Then you have to traverse from this point to this point. And suppose if you sort it in descending order, then you have to traverse from this point to this point. So I'll just sort it in ascending order, because there will be less code. Then I don't have to write that reverse order condition there. So collections dot sort, collections is nothing but this is a framework that ArrayList implements. Collections is the the root of all this thing. So okay, so collections dot sort factors. If you do not understand that how this inbuilt library function is functioning, so you must check out some GFG articles that which data structures implement which framework, right? Okay. So here goes our step 3. Now the step 4. So what computations I need to do for this possible G? So first of all, let me write a loop, right? I will check for all the possible G. So I will start, since I've sorted in ascending order, I will start from the last. So I will say that factors dot size -1 greater than equals to 0, I minus minus. So I iterated. Now what I need to check. So let me tell you now. So suppose, so I need to check that the highest factor of this sum, that is dividing k pre-sum values, right? Why I need to find the pre-sum values? Because this S1 is actually presenting the sum, right? The sum of the elements we took. Suppose in this case for 1, 4, and 5, the 1 and 4 was pointing to S1 and S2 was pointing to 5. So okay, so let's make a pre-sum array. So for 1, 4, and 5, I can say the pre-sum will be 1. Let's make a pre-sum array, right? Let's do this manipulation. We can do this manipulation in the same array itself. So let's say the array is updated now to 1, and 1 plus 4, that is 5, and 5 plus 5 is 10. I'm just adding it 1, then this element will be the sum of this element as well as the left half, right? Similarly, this element will be the sum of this one and the left half. Okay, so it's 10. So this is actually the thing, right? So suppose on this point, then I can say that the S1 is just 1, right? And suppose I'm at this point, then I will say that I have considered 1 comma 5. And suppose I'm at this point, then I will say that I have considered the elements 1 comma 5 comma 10, right? I hope this point is clear to you. So let me write it again: 1 comma 5 comma 10. This is our updated array with the pre-sum values. And now I have G array, G G factors, uh, G factors array list I have, right? And I have sorted it in ascending order, so it will look like 1 2 5 and 10. So what I need to see, I need to start from here. So I started from the pointer that is actually pointing to 10. And what I need to see, that if this current sub array possible, right? I need to see that if this sum is divisible by this. So I will check that if 1% 10 is actually possible or not. So it's not possible, right? So I will check, then 5% is possible, it is also not possible. Then I'll check 10% 10, is it possible? So it is possible. So I will maintain a count, and I will do count plus plus. So now count was pointing to 1, right? And I will say that the sub array 1, at this point it was saying that divisible, right? So I need to consider the elements from this index to this index. So what was our element was 1 4 and 5. So I can say that the sum of this 1 4 and 5 will be divisible by k. But since count is equals to 1, then I'm saying that there is only one possibility, of sub array found that can be divisible by 10. So this answer is not possible, right? Because k is equals to 2 here, given in the question. So I will check for 5 now. Let me change the color. Hmm. Let me take this one. So for 5, I will see that what? This is the pre-sum, right? This is actually saying that what are all the sub-arrays we can take. So I will see that sub-array 1% 5 is equals possible or not, equals to 0. So it is not, right? Then I will see that 5% 5 is equals to 0. So it is. So that means that I can take the first two element as S1. So I will do count plus plus, and count is pointing to 1 now. Then what I will do, then I will check with the second, the last presum, that is 10% 5 is equals to 0. It is. So this is saying that I can take the second sub array as this element. Since I have taken 1 and 4 as S1, and the overlapping is not allowed, so I can take this last element as our what? S2, right? Right. And as you can see, this 5 is actually the divisor of this 1 and 4, the sum of 1 and 4, that is 5, and this S2. So I will do again count plus plus, and now it is equals to 2. And since we found this thing, right? So after each and every loop, I will just say that if count is greater than equals to k, right? Then what I have to do, then I need one answer variable. I will just store this I, let's say this was the ith pointer I'm iterating, and this was the jth pointer. So I will say answer equals to I, and then I will break it from here, break it from there, right? So in this case, I will break from here. I will not check for 2 and 1, right? But let's say suppose if we check for 2 and 1 also. So for 2, I will say that 1 divisible by 2 is not possible. 5 divisible by 2 not possible. 10 divisible by 2 possible, right? So only one sub array is possible, that is 1 comma 5 comma 10, right? No, sorry. Only one sub array is possible, that is 1. That is either you take 1 comma 4 comma 5, or you take just 4. But you can form just one, because there is no overlapping. You cannot use one element twice. So these are all the possibilities: either you take this one, or either you take this one. So this count is actually saying that the number of sub arrays you can take. For the last element, one is divisible with this is one, right? One is divisible with all the possible sub arrays sum. So count will be here equals to 3. And as you can see that you can find the three sub arrays here: 1 comma 4 or this 5, right? You need to consider all the elements. So there is no overlapping around, and this is the three possible sub array you can found. But the k is equals to 3 is not required here. We just found k equals to 2, and I will break it from here, right? Okay. So let's do a dry run for one more case to get a clear understanding, and then we will code ahead. I will try one more test case for you, just to give you a clear understanding. Previously I took elements 1 comma 4 comma 5, right? Test case 1 is too large, so I will take let's say 1 comma 5 comma 6. Let's take it. And the G is the highest factor of sum, and sum is what? Sum is equals to 6 plus 5 12, and factors of 12 is what? It is pointing to 1 2 3 4 6 and 12, right? So we'll start checking from this direction, and before that we need to compute the pre-sum that will actually tell us the number of possible sub arrays we can take. So pre-sum will be 1 comma 5 plus 1 6, 6 plus 6, that is 12. So I started from this pointer 12, right? For this 12 I will check that 1% 12 is equals to 0, so it is not. So 6% 12, it is not, and 12% 12, it is yes. So the only, so S1 is pointing to 1 comma 5 comma 6, right? So count plus plus and it comes to 1, but still the required key was 2, so we cannot do anything from here, right? So we will go check for the next element, that is 6. That is 6. Now the pointer is here, so I will check. So I will again check that 1% what 6. These are the elements I'm checking for. 1% 6, then I will check 6% 6, and I will check 12% 6. So it is not equals to 0, but it is divisible and it is divisible. So this is saying that you take S1 as 1 comma 5, the first two elements, and you take S2 as the last element, that is 6. And as you can see, the sum is 5 plus 1 6, right? This is divisible by 6. So here it will be count plus plus, so it becomes 1, count plus plus, it becomes 2, and since we just needed k equals to 2, right? So it will fall into the case of is count is greater than equals to k, then store that answer is equals to I. This is I, this is the ith pointer I am iterating for. This is the ith pointer, answer equals to I, and we just break it from there, right? So I hope you're clear. And also let's since this test case is not given in our case, so let's just dry run it and we will see that our logic and our code are on the same page or not. So there were three elements. I took the k as 2 and the elements were 1, 5 and 6, right? So let's compile and run and see that 6 came as answer or not. So if it came, then we'll directly go ahead with our coding section. So exactly, great guys. So 6 came. Let's start the coding. So what I need to do, I need to iterate what I did previously. So for each and every I, for each and every this factors, I iterated in the presum. So I need to calculate the presum first. So let's calculate the presum. So step 4 is, this is not step 4. This is step 5. And the step 4 is to calculate the presum. Presum is what it is indicating. It is indicating the number of, or you can say the possibility of, wait, I'm getting a call. So it is actually indicating the possibility of sub array I can take, right, in my answer, right? Okay, so let's calculate the presum, guys. So for int I equals to 0, I less than n, I plus plus, and okay, and I will say that array of I is equals to array of I plus array of I minus 1. So I have to start from I equals to 1, else it will go out of like index error for minus 1. Okay, great. So I have calculated the presum. Now I have to iterate in this presum array. So I will say for int I, or let's int j equals to 0 to j less than n j plus plus. So I am iterating in presum array, right? Okay, I need to check that if this presum, that is array of j, is divisible by my factors, right? So factors is stored in the factors array list. So factors dot get of I, right? I checked it, and if it is 0, then I will increment count plus plus, and count is nothing but the count of sub arrays. Count of sub arrays I can take. So initially it will be 0 for each and every iteration, and if it is satisfy the condition, I will say that count of sub array plus plus, right? Plus plus. And after each and every iteration, I need to check if my count of sub array has passed the criteria of k, have passed the criteria of k, right? Either it will be greater than equals to k, or maybe it would be exactly equals to k. For both the cases, we need to store that count of sub arrays, that we need to store the factors responsible to get this count of sub array. So factors will get from this thing. So for factors dot get of I from the index I, and then I will say break it. I don't need to check it further. Since I just found the maximum possible G, then I will just break it. So this condition is nothing but of getting the maximum possible G. That is the factors of sum. Hmm. Getting the maximum possible G. Yeah. So that's this if is handling this thing. This thing. That's maximum possible G. Okay, at last we just need to return our answer. So answer. And one thing that we have not initialized the answer, so let's initialize for answer equals to 1 because the minimum possible answer will be 1, right? Hmm. So return answer. So let's compile and run and we'll see for ourselves that if it's running fine. Okay, so it was like capital K and I used the small k. So let's compile and run again. So great, your output and expected output matches. So before hitting the submit button, let's analyze the time complexity. So this for loop is taking O of n time, and this array list is taking O of what? Under root of factors. So under root of factors mean, let me write it here. This is taking n time, and let's say the number of factors are x. So this is taking what? Under root of some time, right? So it is taking square root of some time. And let's say the number of factors were x. So let's say the number of factors were x. So we just sort that array list, and for this is n traversal again, and this is n traversal again, and we decide that the number of factors pre-assume that there was x, right? So this is actually factor. So this will take x into n time. So maximum complexity will be the number of factors into the n. So let's see what n is pointing and what x can be. So n is actually 10 power 4, right? And x is there responsible for the number of factors, and there is no information giving on the number of factors. So number of factors will be nothing but the sum, right? We are calculating for sum, and array of I is given as 10 power 5 maximum. So maximum will be iterating for under root of sum, right? Okay, great. So square root of sum, I can say that it is nothing but square root of 10 power 5, right? I can say that. Hmm. There are n elements, so it will be n elements is 10 power 4, and which will be multiplied into 10 power 5. The maximum elements into the maximum this thing. Possibility. So it will give us some, right? And this will be nothing but the square root of 10 power 9, right? 10 power 9, and square root of 10 power 9 will be equals to what? Somewhere around 10 power 4. Somewhere around 10 power 4. Okay, so we got our range. So x will be somewhere around 10 power 4, and n is also around 10 power 4. So 10 power 4 into 10 power 4, that is 8, 10 power 8. And that so it's very tight bound, but uh, it is less than 10 per less than equals to 10 per so it should get submitted. So let's hit the submit button and we will see for ourselves. Great guys, great. So it was able to pass all the test cases, but one more additional information I need to give you here is, so this square root of sum was actually giving 10 power 4, right? But there is one more way to find the factor. Suppose I just iterate from I less than equals to sum, and I just comment out this line. So now it is going to 10 power 9, this array list, this something, right? So it means that now is x is now pointing to 10 power 9, and then n is 10 power 4, right? So the overall complexity will be 10 power 9 to 10 power 4, that is 10 power 13. So if I now compile and run, then the test case must be passing. Let me just confirm. Oh, okay, the test case is passing, and if I now submit it, then with that 10 per 8 logic, it should give TLE to me. Great guys. So great. So I was able to pass on one more information, just a proof of 10 for 8 logic. And if you do not know this power of constraint, you must look at this video. It will be must be flashing up here. You must look at it. So let's change the code again. And okay, so it was like this. Yeah. So okay. So for you guys, I'm submitting in for one last time. Great, great guys. So it works. So I don't think I need to give a code walkthrough. I've explained each and every step. So let's meet in the next mm, next day of our POTD, that is day 94. And few last thing, that's my DSA repository. We must start and fork to get help with the source code as well as the syllabus mentioned down there. And that's my Instagram channel. You can follow me here and connect me for any doubts and guidance, as well as you can connect me on my LinkedIn also. I'm available for you guys. And thank you so much for viewing my content, viewing my channel. If you're new to this channel, if you like my way of teaching, please like, share, and subscribe so that I can make the new video for you guys with the full energy. Tab tak ke liye, bye bye, take care, keep learning, keep growing, and bye.